Now what we are going to do are some measurements with an oscilloscope, a tool that they are going to need to work with inverter technology. This is the one that we recommend. It is bought on AliExpress and it reaches any part of the world. It is not from a well-known brand, but it is of good quality in the world. We are going to use it to measure what we are talking about, alternating current and direct current. In a moment, we are going to make some measurements of the circuit that we have as a sample with the oscilloscope. But first I have to explain something about the voltages or the data that we are going to find when making the measurements. Something very important to keep in mind that will help them open their minds to inverter technology. This voltage that I put here as an example is a real voltage, and it is the real voltage if you have 220 volts that you have in your home voltage. And why? When we propose to measure alternating current with a multimeter, that is to say AC, in reality what the multimeter is going to be is to measure an average that is approximately by this point. At this point you have 220 volts. It can also be 110 or 127, depending on what voltage you have. The voltage that you are seeing with the multimeter is at this point. This wave and this push of electrons is constantly going up and down. If it were a water pipe, it would be difficult to measure the pressure. Let's look at the comparison of water again to understand better. Now imagine that we have a tank with a conduit and we have it circulating with a certain amount of water. If we cover up here, knowing how much water pressure there is here is not difficult because we have a fixed, constant pressure. But now, let's imagine we have this. I'm going to erase the blackboard. Imagine that we have this, and what the water constantly does is change its level from one side to the other, from one side to the other constantly. What is the problem? Control the water pressure, but since we do not have exact data, we have to see it through an average, and that is exactly what the multimeter does when we want to measure alternating current. It is not a real voltage that is there, but rather average, and it is for that reason we will find a value that is at this point. If we want to know the maximum that there is, in the line that we are measuring 220, if we want to know the maximum voltage that is reached at each peak, we have to multiply the voltage by 1.41, which is a fixed factor or a constant, which we are going to use to solve or know the peak of a sinusoidal voltage of 220. This voltage, R, M, S, the voltage that we are going to get with this count, which is almost 311, this is the peak voltage, and these are the peak voltages. And if we want to know how much voltage there is between this point and this point, that voltage is also used, and we are going to need it. We have to multiply it by 2, and we are going to have 600. Since it is almost 311, we are going to have 321 of voltage. These are always peak-to-peak voltages. 621. All these data that are new to you, I'm going to mark it with color to better identify it. Wait a minute. All these voltages, which are new to many, are all voltages that we have to get used to. If there are 110, they have to change this data to 110 or 127. All this is managed with an inverter. In fact, if you have already disassembled inverter equipment, you will have seen that motor compressors tell us that they work with 310 DC as long as you have 220. And why do they work with 310 DC? Because when we rectify the alternating current, 310 automatically reaches me, and with that the compressor works, then it converts it to alternating current again, that is left for later. But it will work with a DC of 310. This section can be a bit difficult to understand. I recommend that you review it again and reflect on what you have seen. To make it easier to understand, we will now see how it works with the oscilloscope. One more detail, so that you take into account this voltage R, M, S, or the average. In all sinusoidal waves, to know the peak, that is multiplied by 1.41, which is the square root of 2. One detail that I wanted to say is that this voltage is not an invention, but that this voltage, to understand it, would be as follows. What the multimeter does when it has a sinusoidal wave is calculate how much power there is in total. And if this were a direct current, how much would it be equivalent to? It would be equivalent to 220 volts. We are going to be reaching 310. Because the capacitor is going to be raising the voltage a little more, it is going to be filtering. But if at this power it were converted directly into direct current, it would equal the voltage, RMS. Now we will leave theoretical explanations and drawings aside, and we will move on to make measurements with the oscilloscope.